Algebra 1, Section 5.2, identifying relations and functions. Some definitions here. I just copied this off my teacher notes here. It's about the best way that I could get this information to you, short of actually writing it out myself, saving myself a little time here. Sorry if it looks a little sloppy. I wrote this about 12 or 13 years ago. It says a relation is a set of ordered pairs. A relation can be a function, which we're about to define. It does not have to be a function. It can be something that's continuous that you draw. Think of a line, think of a circle, think of an ellipse, which you might call an oval, but the math word is ellipse. Think of a parabola, which is what quadratics will produce. Any of these things, also just a set of points where it's just like dot, 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 5 different points. These are all relations. A function then is a specific kind of relation that assigns exactly one output value for each input value. This is an important definition for now and forever, to understand that a function is a relation that assigns exactly one output value for each input value. Now, what that means is that there are no repeats in the domain. There are no repeats in the x, okay? So if they give it to us in like a list of ordered pairs, like x, comma, y ordered pairs, we would look at each one of the ordered pairs and see if we can identify a repeat in the x's, the first numbers. And if there is, well, that would mean that the relation is not a function, okay? Same thing if they gave it to us in like t-chart form, in a table of values. We would be looking for a repeat in the x. If we didn't find any, it is a function. If we did find one or more than one repeat, then the thing is not a function. Okay, and then that asks us then to look at example A on this worksheet here. So it says, again, here's that definition again. In the relation using brackets, you can list the set of ordered pairs in a relation using brackets. The brackets are shown there, right? Actually, I think that's actually braces, not brackets, but braces. Probably when we typed this, we didn't know the difference. Anyway, in example A, notice that there's 11, 12, 13, 20. See any repeats in the A? Okay, so this is going to turn out to be a function. That definition actually comes next. A function is a relation that assigns exactly one output from the range value for each input from the domain value. And that's from section 1.4, that terminology from domain and range, okay? So it says take example A and make a mapping diagram. I'm about to show you what a mapping diagram is. And those input values, 11, 12, 13, and 20, they go here. Why is that not working? Oh. Got to have a visible color. And then these are the range, these are the elements of the range. Now, a point that I would have made in chapter 1, let me make it again. There are not multiple domains for any single relation. The domain is this, right? The domain is 11, 12, 13, 14. The example I like to use is the freshman class. The freshman class is one class. There are 300 or more elements in that class, but the class is one. The people in it are many. There's one domain and many elements in the domain. Outputs, you have -2, -1, -2 again, and 7. You do not need to list that number twice. In fact, you should not. I do like it when you put them in numeric order like I have done here. Now again, a mapping diagram then connects things as the ordered pair does. So 11 connects to, or we say maps to, -2. 12 maps to -1. 13 maps to -2. That's a -2. I kind of covered that up there. And then 20 maps to 7. Now again, this is a function based on this definition because for any input, there is a unique output. You put in 11, you're going to get -2. You put in 12, you're going to get -1. You put in 13, you're going to get -2. You put in 20, you're going to get 7. It is not a problem that there's this output -2 for 11 and 13. As what I mean by problem is, it's not going to cause it to not be a function. We would be looking for repeats in the 11. Repeats in the domain where the 11, 12, 13, 20 is. If there were two or more arrows leaving from any one of these elements, that's going to cause it to be not a function. Okay, let's do the same thing here for B, and we'll see one that is not a function. -2, -1, and you see that you have you have 6, and then you have -2 again, right? So the outputs being -1, 0, 1, and 3, you can still make a mapping diagram, whether it is a function or not. -2 maps to -1, -1 maps to 0, 6 maps to 3, and -2 maps to 1. It is this right here that causes this to not be a function, the fact that you have 2 arrows leaving from -2, which pairs very nicely with what I said earlier. You're looking for repeats in the x, right? So this is not going to be a function. But anyway, we're going to talk about that in just a second. The more important thing for this moment is the mapping diagram, okay? And there it goes now. So which relation above is a function? We've already said that example A is a function. Example B is not a function. Why? Well, I won't write the whole thing out, but you could say one output for each input. And example B has 2 outputs for an input of -2. Okay, so let me say that again. That the explanation as to why, this was example A, I forgot to write A. The explanation as to why is because in example A, there is one output for each input. Each input has exactly one output, not more than one. Okay, and then example B is not, because there are 2 outputs for -2 as an input, right? Now, back to this page. We're here now. The vertical line test. The vertical line test is often abbreviated like this, VLT. I like that. If any vertical line passes through more than one point on the graph of relation, then for some value x, there is more than one value for y, which implies then the relation is not a function. And we often will say it fails the vertical line test. I am totally fine with the language as you get to understand functions of something. Yes, it's a function because it passes the vertical line test. No, it's not a function because it fails the vertical line test. However, long term, you are going to want to steer towards the explanation of input-output. For every input, there's exactly one output, therefore it's a function. Or it's not a function because there's more than one output for any particular input, right? You're all pre-calc bound. That's what they want to hear, okay? It demonstrates a deeper understanding. Now, with that, let's go back to an example here. And we're just looking here at example C, and I can plot these points. We have 4, 3, just plotting ordered pairs, and 2, -1, and -3, -3, and 2, 4. Now, did you hear me say 2 twice, just like in the problem above that was not a function? I said 2 twice, or it's written here twice. You have a repeats in the x. The way that manifests itself on a graph is that they are top to bottom to each other. Okay, so there's a vertical line that would pass through those 2 points. This is what I would say fails the vertical line test. If it passes through the function, if it passes through the relation more than once, it's not a function. Here you have 2 points that are top to bottom. This is not a function. Okay, now let's do the other one. You have -4, 0. You have 2, 12. Well, that's going to be way off the graph here, but it's somewhere up here. -1, -3, and 1, 5. This one will pass the vertical line test. For every input, there is a unique output. You can't find a vertical line anywhere on here that would pass through more than one place, one point in this case, on this relation. So this would be a function. This was not a function, whereas this one over here is a function. Now look, where we go with this is not where we are right now. You must understand that we're not going to deal with problems with 4 points for very often. It's much easier to talk about a line or an absolute value function or a parabola or an ellipse. And would these pass the vertical line test? Real quick. Yes. This is a function. There's no place where it passes through the function, a vertical line. And I don't mean a particular vertical line, and I don't mean the y-axis. I mean any vertical line you can come up with that would pass through that relation more than once. So this is a function. Any vertical line that you could find that would pass through this more than once? No. What about a parabola? No. These are all functions. What about an ellipse, though? This one would fail the vertical line test. If this is, let's just say this is the point here, or the tick mark on the x-axis of -3, right? This might be, -3 comma 2. This might be -3 comma -2. The repeat in the x causes this, that is the vertical line test, to fail. -3 doesn't have a unique output. This would not be a function. Okay? Almost done? Quickly here, function notation. You're going to have to start getting used to this kind of thing. This does not mean multiplication. That is not f times x. The way that is pronounced is simply f of x, f of x. And that is just Euler's function notation. And there's a reason that we have that. I'm going to illustrate that in one of the last examples, maybe both. But these basically, you just need to understand that f of x means y. These are the same thing. And again, I'll illustrate why we don't just stick with y. But don't think that it's multiplication. Don't think that it's something confusing, because it's not. It's just a couple of new words, f of x, and it stands for the dependent variable. It just means y. Okay, the dependent variable y. Okay, lastly, these two examples make a table for f of t is equal to 0.5x plus 1. Again, it's terrible that they do this right from the start. That forget about t. It's f of x. Okay. F of x is equal to 0.5x plus 1. Here's what you need to know. You're familiar with a table of values, right? Here's x. They give us 1, 2, 3, 4. They also give us 0.5x plus 1. And then the output would be what you're used to probably calling y, that we're now going to call f of x. Okay? So what happens when you plug 1 in for x? Or what happens when you plug 2 in for x? And then 3, and then 4. And then we're just going to evaluate these. Half of 1 is a half, plus 1 would be 1.5, or 1.5. Half of 2 is 1, plus 1 would be 2. Half of 3 is 1.5, plus 1 would be 2.5, or 2.5. And this one would be 3. Okay? Now, it does say use 1, 2, 3, 4 as domain values. The way we do that, as we kind of outlined in the on the worksheet, is to use braces. 1, 2, 3, 4. That's the domain. Domain is this. So I'm going to list the range in the same way. This is the range. 1.5, 2, 2.5, 3. Okay, that's all. F of x is equal to 0.5x plus 1, and they give us particular inputs for the domain. We have some matching outputs that make up the range. That's exactly what they have there. All right, now evaluate the function rule f of g is equal to -2g plus 4 to find the range for -1, 3, 5. Again, it's almost the same question. They're just modeling it a little bit differently. And I do want to emphasize now function notation. So what's the point to this? Why is it f of g? Why don't they just stick with y? Well, here's why. Because you can go f of g, where g is -1, equals -2 times -1 plus 4. You're replacing g with -1 not only there, but also there, right? So you can basically see what your input value is within the dependent variable there. And we'll do that. And then f of 3 is going to be -2 times 3 plus 4. And then f of 5, because they gave me -1, 3, and 5, f of 5 would be equal to -2 times 5 plus 4. And quickly do the math here. Look at how much work they're going to show here. Do you need 4 lines of work for each one of these? If you do, that's fine. You probably don't, though. This is 2 plus 4 is 6. This is negative 6 plus 4 is negative 2. This is negative 10 plus 4 would be negative 6. Now, especially because they gave it to us like this in domain, I would like the answer to be the same way as the range. 6. Actually, I do prefer numeric order. Not a right or wrong thing, but I like negative 6, comma, negative 2, comma, 6. The domain and range don't have to match up that because negative 1 gave you 6, that's got to come first. No. What's best to list for domain and range is just smallest to largest. All right, and that's all. Thanks for watching.